Hey guys, welcome back to the continuation of the lecture related to ionic equation. We have practiced few of the equations earlier in the video number 1 and video number 2 of ionic equation. Here I have this equation. I have solved this equation in the previous video as well. I am going to elaborate this equation again so that you people may develop a confidence in solving such type of equations. Here we know this thing that we have this chlorine, okay? And first of all, we should know this thing that in this reaction, chlorine is reacting with sodium hydroxide, making two types of the chlorine compounds, NaCl and NaClO, along with water. First of all, we should look into the fact that either the equation is balanced or not. Okay. Now check how many chlorines are there. Two chlorines are here. So one chlorine is here and the other chlorine atom is here. So it means that chlorine is okay. Now the scene of NaOH is started. Let's look at NaOH. How many NAs are there? Two NAs are there. So one NA is here and the other NA is here. Okay, so NA is okay as well. What about the oxygen atoms? There are two oxygen atoms. One oxygen atom is here, whereas the other oxygen atom is here. So we can say that oxygen is okay as well. What about the hydrogen? There are two hydrogens, so there are two hydrogens in H2O. So we can say that H2 is this hydrogen is okay as well. Now we are going to find out that how to write the balanced ionic equation. We can look into this equation. We are going to consider Cl2 as a gas, so it is considered as insoluble. What about the sodium compound? It will be considered aqueous, as all compounds of sodium are aqueous in nature. I mean to say they are soluble in water without any exception. Similarly, NaCl is also aqueous. It is soluble in water. NaClO is also soluble aqueous as well, soluble in water. Okay. What about water? We are going to consider water as a liquid substance. That's why we are going to write L for this. So a Cl2 being a gas will not be converting itself into its components. It is NaOH which is forming 2Na plus 1 along with 2OH 1 minus, and NaCl is converting itself into Na plus 1 plus Cl 1 minus plus we can say that NaClO is forming Na plus 1 plus ClO 1 minus. Okay, and water will be as it is. Okay, so here I'm writing these plus the different products are separated with these blue plus. Okay, and here I am telling you, oh, here I am telling you that this is this plus. Okay, and this is like this. Okay, now look at the what are the spectator ions here? It is Na, spectator ions 2 times Na. So we are going to cancel this. And the remaining ions are not spectator ions. So we are going to write this equation. This is the sum up equation, and that is 2OH here in the reactants. And then it is left with 1Cl plus 1ClO1 minus plus H2O. Okay. So this is the sum up equation for this reaction. And regarding the solubility, one should know this thing that we have considered NaCl soluble because it is a compound of sodium. We have considered NaClO soluble because it is a compound of sodium. We have considered NaOH soluble because it is a compound of sodium. So I am giving you a reminder that all compounds of group number 1 will be considered as soluble. Okay. I am on the next equation. It is a reaction between potassium hydroxide and ammonium nitrate. Potassium hydroxide is a base. It is a water soluble base, so it is considered as an alkali. Okay. What about the ammonium nitrate? It is an ammonium compound, so it is acting as a fertilizer. Okay. What is a fertilizer? It is a substance which is used for the promotion of the plant growth. Okay, and it is an ammonium compound as well. Okay, these are the informations which we know already. Okay, ammonium nitrate, and it is an ammonium salt or ammonium compound. Okay, we are going to convert the substances into their components. It is K plus 1 plus OH 1 minus plus NH4 plus 1 plus NO3 1 minus. Why? Because we know this thing that all compounds of group number 1 and all compounds of ammonium are soluble. So it is K plus 1 plus NO3 1 minus, and here it is H2O along with NH3. We are not going to convert NH3 into its components, and we are not converting this water into its components as well. Water will be liquid. Okay, so now we are going to select the spectator ions. It is K plus 1 and NO3 1 minus, which are the spectator ions. So what will be the remaining equation here? It will be OH 1 minus plus NH4 plus 1 arrow H2O plus NH3. So these are the components of the reaction and the products here. These are the ions, you may say, the reactants, and the products are written now. Okay, so this is the way to write the ionic equation for the reaction between an alkali and you may consider a fertilizer, which is ammonium salt actually. Okay, so right now there is another example in which you may say it is metal metal displacement reaction, metal dash metal displacement reaction, in which one metal is displacing another metal. Okay, so here the first is the salt. Why it is iron salt? How we know? The compound of a metal with sulfate is considered as a salt. If you are going through the videos of the salt, you can see this thing, that definition of the salt is telling you that combination of any metal ion or ammonium ion with the negatively charged ion or a negatively charged radical is called a salt. So here it is metal combination with sulfate, it is called as salt. Just hydroxide is also a negatively charged radical, but it is making its combination with the metal is making metal hydroxide, which is not a salt, rather it is a base. Okay, so that's an exception. Okay, now that's an exception, and in addition to that, metal oxides are also a combination of metal with negatively charged oxide ion, and that is also considered as a base. Okay, so these are the some exceptions in which you need to look into very clearly, that where we have to know that where is the base and where is the salt, and what is the definition of a salt and what is the definition of a base. Okay, now I can say that iron sulfate is converting itself into its components, and what are those? Fe2 plus and SO4 2 minus plus 2Na plus 1 plus OH1 minus. Okay, before moving ahead, I should tell you about the solubility of iron sulfate. It is soluble, that's why I have converted into its components. I am writing aqueous. How I know it is soluble? Because all sulfates are soluble except lead, barium, and calcium. So iron sulfate will be considered as soluble. Okay. So what about the ions of the products? It will be FeOH twice as it is, because it is insoluble. All oxides and hydroxides are insoluble except for group number 1, ammonium, strontium, and barium. So iron hydroxide is insoluble. And what about the sodium ions? It is Na plus 1 from sodium sulfate. Along with that, it is SO4 2 minus, which are forming from sodium sulfate. So now what are the spectator ions? It is Na, SO4, Na, and SO4. So now what is the resultant equation which is left at the end? It is Fe2 plus OH1 minus. It is 2OH. It is 2OH1 minus arrow FeOH twice. Okay, I should write solid over here, I should write aqueous over here. Okay guys, I'm telling it to you again and again that state symbols are really important to be written. If you are not writing the state symbols, it can create a confusion for you initially, and then finally examiner has a right to cut your marks as well. So please, while writing ionic equation, it is highly advised to write down the state symbols as well. So I'm writing aqueous over here, I'm writing the solid symbol for this, and this is aqueous as well. Okay, so this is how we are going to write down the ionic equation for this. There is another reaction. It is also a metal displacement reaction. Zinc is higher reactivity metal as compared to copper. I will teach you about the reactivity series of the metals as well. Reactivity series of the metals is basically a series which is just telling you that how we can say that what is the reactivity of a metal. According to that reactivity series of the metals, the one which is higher in the position in the reactivity series is considered as higher in the reactivity as well. Okay, zinc is higher in the reactivity as compared to copper. So zinc has an ability to displace copper from its compound, will make its own compound, and will make copper out of the compound. Okay, so this is zinc, which is considered as solid, and this copper sulfate is aqueous, and copper is solid, whereas zinc sulfate is aqueous. So it is Zn, and it is converting itself Cu2 plus and SO4 2 minus, and it is Cu then, because it is in the solid state, and after the reaction Zn will be like this. Okay, so we can say this thing that we are now going to design the ionic equation, before moving there, I am telling you that what are the spectator ions. Okay, so these are the spectator ions. Here it is in the solid state, it is in the aqueous state. Here it is in the aqueous state as well. So what will be the resultant equation? It is this resultant equation. And please, I am telling it to you very clearly that this is one of the famous question. Okay, so please don't forget that you have to write everything so that you may be able to score 2 or 3 marks associated with such type of an ionic equation. Okay. Afterwards, I am taking you to the next example. This is NaOH. Okay, so it is considered as aqueous because all compounds of sodium are soluble in water. Chlorine is a gas, whereas NaCl is considered as aqueous. NaClO3 will be aqueous as well and liquid as well, water. Okay, guys, this is the reaction of chlorine with sodium hydroxide when it is colder conditions. I have taught you this type of the reaction when I have taught you disproportionation reactions already. So it is the colder conditions, the temperature is approximately, let's see, 20 degrees Celsius. Okay. So this is again the reaction of chlorine with sodium hydroxide. It is in the hotter condition and the temperature is, let's see, 75 degrees Celsius. Okay. So we are going to convert the soluble ones into their ions. It is 6Na plus 1 plus 6OH 1 minus plus Cl2 arrow 5Na plus 1 plus 5Cl 1 minus plus it is Na plus 1 plus ClO3 1 minus plus H2O 3H2O. Okay, so I am writing with different color here so that you may be able to differentiate. Where is the red color? This is red color. Okay, so let me write down the symbols of plus with the red color so that you all may be able to differentiate very clearly. Okay, now, what are the spectator ions? This is not very clear. I should write it very clearly. Okay, so it is 5Cl 1 minus. Okay, it is 5Cl 1 minus. Okay, now what are the spectator ions here? It is Na ions, which are the spectator ions. I'm cancelling with the green color. So it is Na ions here and Na ion here. So total 6 in the products and 6 in the reactants. And now we are finding the Cl ions. They are Cl ions in the products but not in the reactants. OH is ionic form in the reactant but not in the product. So what will be the resultant equation? It will be 6OH 1 minus plus Cl2 arrow ClO3 1 minus plus 3H2O. Okay, 3H2O. So this is how we are writing the balanced chemical equation, and along with that 5Cl 1 minus are there as well. Okay, and here as the 3Cl2, it is 3Cl2, which I should write 3Cl2 plus 3Cl2. Okay, so so that the equation may be balanced. Okay, 3Cl2. In this way you can see this thing, that how many Cl's are there? 6. One is here and 5 are here, so 3 and 3 Cl2 are making 6 and 6 are here. Okay, what about 6O? 3 O's are here and 3 O's are here. What about the hydrogen? 6 hydrogens. 3 into 2 is 6. So you can see this thing, that if you are writing the balanced chemical equation at the top, after cancellation of the spectator ions, the remaining equation still remains a balanced chemical equation. Okay, still a balanced chemical equation. So please be careful about that, that you are going to write a balanced chemical equation. I'm going to take you from the first example of this topic, ionic equation. In the first video of ionic equation, I have explained this example, NaOH and HCl, and I have told you very clearly that this is the equation for neutralization reactions between an alkali and an acid. This is another reaction in which barium hydroxide and other base is reacting with nitric acid. Again, the same type of the product, again, the same type of the resultant equation with different balancing, but the same equation. Here, it is an insoluble salt. Barium sulfate is formed from the two soluble partners and making the insoluble product BaSO4. You can see how I am writing the ionic equation here. I have explained it in the second video. It is again the ammonium chloride. You know this thing, that it is an aqueous substance because ammonium compounds are soluble, all nitrates are soluble, silver chloride is solid, and ammonium nitrate is aqueous. So Here we have converted what we have converted. We have just converted AgCl into solid. It will be remain a solid, and the remaining spectator ions will be cancelled. If I'm moving on to the question number 5 and 6, you can see then number 5, the reaction between the two different reactivity halogens. So there is a displacement reaction. A more reactive halogen is displacing the less reactive halogen. Similarly, in the sixth one, a metal carbonate is reacting with an acid. As a result, metal chloride, or here the metal salt, you may say carbon dioxide is a gas, so it is not going to convert itself into its components, and water will be remain as it is. Okay. So in number 7, a higher reactive metal is metal oxide is reacting with an acid. Zinc is quite a high reactivity metal. It is reacting with an acid, and as a result of that, metal salt and you may consider water is produced. Okay, so here a reaction can be for zinc and acid as well. So it is forming what zinc sulfate along with hydrogen gas. Equation is balanced. Gas is will be written as it is. It is aqueous, and all acids are aqueous. So it is in the solid state. So we can say zinc and 2H plus 1 plus SO4. 2 minus because we are converting it into its ions. It is this, and SO4 2 minus along with H2 a gas. So here I am selecting the spectator ions, which is this, and the remaining equation is Zn, which is in the solid state, plus 2H plus 1 arrow Zn2 plus H2 a gas. So this is how we are converting the components into the spectator ions, and then selecting the spectator ions on both sides of the equation and cancelling. So in this current lecture today, I have explained you that how we are converting the reaction of Cl2 and NaOH into an ionic equation for the colder conditions, for the hotter conditions in the next page. So this was the reaction of a fertilizer with the base, which is one of the important reaction of the bases. This is the reaction of a base with the metal salt. It is also one of the important property of the bases. In the next one, zinc is reacting with a low reactivity metal salt, that is copper sulfate, and the reaction is the displacement reaction. What is the spectator ions and what are the ionic equation that are done here? Okay. In the next case, you can see the reaction of a hot alkali with what? With chlorine, and the products are different, no doubt. And I have taught you this thing in the chapter of in the topic of disproportionation reactions as well. Okay. So these are the overall 3 videos in which I have solved 12 examples of ionic equation. If still there is any problem, all of you are most welcome to send me any question there on the YouTube comments. I will solve that equation as well for you. Thank you very much. Take care.